I am Shoma Bandyopadhyay, Assistant Professor of Computer Science and Engineering Department of MCKV Institute of Engineering, Lilua, Howrah. Today, I shall discuss about the row measure and column measure ordering of array. Array is a collection of variables of same data type that share a common name. Array is basically an ordered set which consists of fixed number of elements. It is an example of linear data structure. In array, memory is allocated sequentially, so it is also known as sequential list. Consider the following example in which an array of 5 elements is stored sequentially in memory. So here the 5 elements 10, 20, 30, 40 and 50 are stored sequentially in memory location 2000, 2002, 2004, 2006, 2008. A0 is the indices of the array. A1 denotes 20. In A2, 30 is stored. In A3, 40 is stored. A4 indicates the 50. So basically 10 is stored at memory location 2000 and 20 is stored at memory location 2002. Similarly, 50 is stored in memory location 2008. Now, we can calculate the location if we know the base address and the word size and the indices of the array. Here, the base address is the address of the first element in the array. W means the word size. It denotes the number of bytes occupied by each element. So if we consider the integer type of data, we can consider 2 bytes of memory location will be occupied by the integer type data. Suppose we want to calculate the address of element A2. Here 2 is the indices of the array element. It can be calculated as using this formula. So here the base address is 2000 and W equal to 2. So location AI indicated the base address plus W into I. So here the value of I equal to 2, W is equal to 2. So here we have calculated 2 into 2, that is 4. The base address is 2000. So the location of the element A2 is in 2004 memory location. So in previous slide, we can see that A2 is stored in 2004 memory location. Okay. So now we can recall that each dimension of the two-dimensional array is indexed from 0 to its maximum size -1. First index selects the row and second index selects the column. The two-dimensional array is treated as a collection of 1D arrays. Now, the computer memory is an one-dimensional sequence of bytes. In computing, the row measure order and column measure order describe the methods for storing multidimensional arrays in linear memory. That means the computer memory is one-dimensional, and in computing, the row measure order and column measure order are the method of storing the multidimensional array. So there should be a standard location. Rows are identified by the first index of the two-dimensional array and column is identified by the second index. So now we know that array layout is critical for correctly passing the arrays between the programs written in different language. For row measure order, that means in C language the row measure order is used and column measure order is used in Fortran and in MATLAB. Now we can illustrate the basic difference between the row and column measure ordering. Although we have shown a rectangular picture of a two-dimensional array, these elements will be actually stored sequentially in memory. Since computer memory is basically one-dimensional, a multi-dimensional array cannot be stored in a memory as a grid. There are two ways of storing a two-dimensional array in memory. So first one is the row measure order and the second one is the column measure order. So let us discuss the elements of a 2D array that are stored in row measure order. Here, the elements of the 0th row are stored before the elements of the first row. The elements of the first row are stored before the elements of the second row. So, in case of row measure order, the elements are stored in this way. 1, 2, 3, then 4, 5, 6, then 7, 8, 9. So, the row of 0th row will be filled first, then the first row will be filled, then the second row will be filled. When we store the elements in a column measure order, the elements of the 0th column are stored first. Then the elements of the first column will be stored. Then the elements of the second column will be stored. So how the elements will be stored? Element will be stored in this order. Okay. So here how the element will be stored? First one will be stored, then 2, then 3, then 4, then 5, then 6, then 7, then 8, then 9. So in case of row measure order, the elements will be stored like this. And in case of column measure order, the element will be stored like this. Now, the row measure order is a method of representing the multidimensional array in sequential memory. In this method, elements of an array are arranged sequentially row by row. Thus, elements of the first row occupies first set of memory locations reserved for the array. Elements of the second row occupies the next set of memory location and so on. So here as I have indicated here first row, it means when you will indicate the first row as 0 index and the second row as the index of 1. So that means it is basically the 0th row or it is basically the first row. So you indicate this as the 0th row and first row. Okay. So in this case, consider a two-dimensional array consists of n rows and n columns. So it can be stored sequentially in memory row by row. So row 0 means A00 to A0 m minus 1. In row 1, A10 to A1 m minus 1. Similarly, in row 2, A20, A21 to A2 m minus 1. In row n minus 1, a n minus 1 0, a n minus 1 1, a n minus 1 n minus 1. Thus, the elements are stored in the memory location. That means in two-dimensional array, if it is consists of n row and n columns, it can be stored sequentially in memory row by rows. First, this row will be filled up, then this row will be filled up, then this row will be filled up, and so on. And at last, the last row will be filled up. So now, if we consider the following example, in case of row measure order representation of an array, we can say that the two-dimensional array consists of 2 rows and 4 columns that is stored sequentially in row measure order in this example. So A00 that is located at 2000 location, A01 element is located in 2002 memory location, A02 element is stored in memory location 2004. Thus, A03 element is stored in memory location 2006. So these are the elements of row 0. Now, The elements of row 1 is A10, A11, A12, A13, which are stored in the memory location 2008, 10, 12, and 14. Now, if we calculate the location of the element Aij, we can calculate the location by evaluating the following expression. Location Aij equal to the base address plus W into M into I plus J. Here, the base address is the address of the first element in the array. W is the word size. It means the number of bytes occupied by each element. N is the number of rows in the array and M is the number of columns in the array. I and J are the subscripts of the array element. Now we can write the formula location Aij equal to base address plus W. W is the word size. M is the number of columns in the array and Ij are the subscripts of the array elements. So I indicates the row indices and J indicates the column index. Now suppose we want to calculate the address of element A12. So it can be calculated as follows. If we consider the base address 2000, W equal to 2, M equal to 4, N equal to 2, I equal to 1 and J equal to 2. Then location Aij, that means location 1, 2 will be calculated like base address 2000. Then in place of W we can put 2. Then M equal to 4. That means number of columns is 4. In this case, we have considered 2 cross 4 matrix. Number of row in my example is 2 and number of column is 4. So here M equal to 4. Now 4 into 1. 1 means the row indices of the array, row index of the array. 2 means the column index of the array. So in case of J, we placed here 2. In case of I, we placed here 1. So 4 into 1 equal to 4 plus 2 equal to 6. 6 into 2 means 12. So the location is 2000 plus 12, that is 2012. So the base address was 2000, width equal to 2, number of column equal to 4, number of row equal to 2, the index of the row is 1, the index of the column is 2. Now we can calculate the location of A12, that means the address of element A12. If we calculate by using this formula, we can get the result 2012. That means the address of the element A12 is 2012. That means this element is stored in the location of 2012. Now, if we consider the column measure order representation of array, column measure order is a method of representing multi-dimensional array in sequential memory. In this method, elements of an array are arranged sequentially column by column. In the previous example, we have already shown that the elements were stored in column by column in case of column measure ordering. So now we shall discuss details about the column measure ordering. So in this method, the elements of an array are arranged sequentially column by column. Thus, the elements of the first column occupies the first set of memory location reserved for the array. Elements of the second column occupies the next set of memory and so on. So, if we indicated the first column at 0th column, as in case of index we have shown by 0, and the second column will be indicated by the 1 indices. Okay. As we are starting in case of array, we will start from 0th location. That means the first column will be indicated by 0 indices and the second column actually will be indicated as 1 indices. So we can consider it as 0th column, this as first column instead of first and second column. Now I shall discuss about the column measure order representation of array. Consider a two-dimensional array consists of n rows and m columns. It can be stored sequentially in memory column by column as shown below. So in column 0, column 1, column n-1, so A00 element will be stored in column 0, A01 element will be stored in column 1, A0m-1 element will be stored in column n-1. Similarly, A10 element will be stored in column 0, A11 element will be stored in column 1. So it will be stored in column by column. Okay, like this, the element of a n-1 0 will be stored, a n-1 1 element will be stored, a n-1 m-1 element will be stored in the last column. Now if we consider the following example, we can discuss about the location of element aij. It can be obtained by evaluating the expression location aij equal to base address plus w into n into j plus I. Here the base address is the address of first element of the array. W is the word size. It means the number of bytes occupied by each element. N is the number of rows in the array. M is the number of columns in the array. I and j are the subscripts of the array element. I is the index of the row and j is the index of the column. So if we calculate the memory location, we can calculate by the using of base address, by the word size, then the number of rows, then the number of then the indices of the index of the column plus the index of the row. So let us give an example. Suppose we want to calculate the address of element A12. We will calculate the address in column measure array representation, column measure order representation. So here the base address is 2000, W equal to 2, M equal to 4, N equal to 2. We have given the example N equal to 2, M equal to 4. That means the number of rows equal to 2 and number of columns equal to 4. So it is 2 cross 4 matrix. I equal to 1 and j equal to 2. So array index, row index of the array is 1, column index of the array is 2. So we can calculate by the help of the following expression: base address plus w into n into j plus I. So here the in place of base address we can put 2000 plus with w equal to 2, start 2 into 2 plus 1. So we can calculate 4 plus 1, that is 5, 5 into 2, that is 10. So the memory location is now 2010. That means in column measure ordering, the element which is A12, the address of that element is 2010 memory location. So in case of column measure ordering, it is stored in 2010 memory location. A12 element is stored in 2010 memory location in case of column measure ordering. And when we were calculated the row measure ordering, we calculated the location as 2012. So A12 element location memory element, A12 element was stored in the memory location 2012 when we calculated the row measure order. Okay, so in case of row measure order, the location is 2012, and in case of column measure order, the location is 2010. So this is your assignment. Consider a 20 cross 5 two-dimensional array Mars which has base address 1000 and the word size equal to 2. Now you have to compute the address of the element Mars 18,4. That means here the row index is 18, column index is 4. assuming that the elements are stored in row major order. Similarly, you have to compute the same, assuming the elements are stored in column major order. So you have to calculate this. This is your assignment. Okay, thank you.